Dear students, teachers, and parents, okay? My name is Frederick FONG from Hong Kong UST Department of Math, okay? And so today I'm going to talk about, several things, including what university level math is about, so what kind of math you will study if you're enrolled in the Bachelor of Math program, okay? And also what's so special about Hong Kong UST Math, okay? And also speak about some of our notable students, alumni, and etc. Okay, so let me begin with a very brief introduction of what university math is about. Okay, it appears to be very different from what you are learning in high school. Okay, in high school you divide several topics into algebra, calculus, and statistics. Okay, and well, in university we don't classify math in this way. Okay, I mean we also have statistics, we also have algebra, calculus, but the major categories that we will divide is it's mainly pure mathematics, okay, applied math, and also statistics, financial mathematics. So we categorize mathematics fields into these three categories, okay. And let me say a few words about what each of these categories. Let me say something about what these three categories is all about, okay, by maybe some examples of topics. Okay, so let me begin maybe with pure math, okay, and so to put it in a more formal way, what pure mathematics is about is basically studying some fundamental or abstract concepts, okay, and also study some deep relation between them. So what it means is maybe I take an example to explain it, okay. So one example of pure mathematics topics, okay, maybe about so-called prime numbers, okay. So what a prime numbers is about is a number, okay, you see in the slides here, okay, is each of the number here, they're integers, okay, and they're integers that is only divisible by itself and also the number 1, okay. There's no other positive integers that can divide each of these numbers, okay, and then we call them prime numbers, okay. And if I ask you a very simple question, what is the 5th prime number, okay, then I believe that many people will agree that it's 11, okay, if you just count 2, 3, 5, 7, and 11. Okay, and if I ask you what is the 10th prime number, then that's 29. Okay, well, if I ask you a little bit more challenging question, what is the 100th prime number? I think you can still have some efforts writing down all these prime number one by one. Okay, I believe that you can still count what is the 100th prime number. Okay. But if I ask you a very difficult question, what is the 1 millionth prime number, then that's not really easy to answer, okay? And actually, we don't even have a formula for us to calculate what is the nth prime number, okay? But in number theory, which is probably a year 3 or year 4 course in the pure math track in the program, okay, is that we have something called prime number theorem, okay? And I copied that in the lecture notes, okay? What I wrote here is the statement of the theorem, and in the science it's very difficult to understand for a high school student. But if you just look at the last line, okay, the last line said that the nth prime number is roughly equal to n times log of n, okay, the natural log of n, okay. So if you try to see what is the 1 millionth prime number, so you just put n equal to 1 million, and then you put it into n log n, okay, and that number, that output, okay, will be approximately equal to the 1 millionth prime number, okay. And so, well, in university mathematics, you are not only just know how to plug things into formulas, okay, you also have to know why, okay, what's the proof of the theorem, okay. Well, of course, today I cannot talk about the proof, okay, but I can give you some idea. It's actually using this so-called Riemann-Zeta function. It's an infinite series defined in the slides, okay. It's a summation over infinitely many terms, okay. And the I terms is actually a complex number I square root of 1, okay. And why complex number has anything to do with integers, prime numbers, is really amazing fact that they can be connected into each other, okay. So that's what I mean by deep relation between them, okay. And so this is one of the topics that the pure math person would be interested in studying is number theory, okay. And let me take a look at another topics. So you can see there are some geometric shapes, okay, on the right, and there's a subframe, and there's an Earth and a universe disturbed by the gravity of the Earth, okay. And then these three things actually can be related to each other, okay. So if you ask the question, what is the geometry of the universe or what is the total mass of the universe, okay? It can be explained by the geometry of soot flames, okay? And also this kind of surface, okay, that I draw on the right, okay? And but that's actually a very deep relation between, okay? And even though in literature you see the problem is about physics, okay? Many of the physics concepts can be explained using pure mathematics, okay? So these are examples of topics. And then it sounds very abstract, okay? Very off the ground, so to speak, okay? And let's look at the other area, which is applied math, is more applicational. So what applied math studying is some applicational problems, okay? And just for example, if you look at the right top corner, okay, there's a paper by our former university president, Tony Chen, okay? Well, in that paper, he published something about how to remove some noise, okay, from a photograph, okay? So if you look at the three pictures here, the first one, there's some text, okay, on top of a photograph, okay? And well, actually what he did in that paper is to derive some mathematical methods so that we can use that to remove those characters, okay, automatically using a certain mathematical way, okay? And after removing those, okay, and also we want to fill up the space that is left off by removing the text, okay? And well, if I ask you to decide what color you have to use, okay, in order to fill up the space, okay, then it should be easy for you, but it's not easy for a computer, okay? If you have to train the computer to fill in the space in between, okay, that requires a little bit of mathematics. In applied math, there's some algorithm that you can use to do this kind of things, okay? And on the other hand, if you look at the lower right corner, okay, there's a photo of mine, and then I take a picture using my phone, and then the app in the phone adds the hat, okay, and then do some funny thing on my hat, okay? And in order to do this funny thing, you have to tell the computer, okay, which part is my nose, which part is my eyes, and which part is my head, okay? Well, it's easy for a human being to identify which part is your eyes. But if you want to train the computer to identify which part is your body part, okay, it's not an easy problem. And then there are lots of mathematics behind for us to do this kind of identification, okay? So that's what applied math is about, okay? You use computers combined with mathematical methods to do applicational problems, okay, in science, in computer engineering, etc. Okay, and also you can see a picture here. How do you fill up the space, okay, using a smart algorithm? Okay, it's all to do with mathematics behind. Okay, and also we have statistics as one of the category in mathematics. Okay, and well we have a data science track. Okay, programs which is a separate program for in the JUPAS, well, in our science school, okay? And so my colleagues will talk more about what is data science, okay, and statistics, okay? And to briefly introduce you what statistics is about, it's not only just like an M1 syllabus, okay? In M1 syllabus, you count what is the probability of having a certain dice, okay? But statistic problem can be much more complicated than that, okay? For example, you have to train the machine to learn something. For example, in search engine, okay, if you type some keywords and it output a list of web page according to how important they are, okay? And how do you tell the computers to determine the importance of all these web page, how to rank them from importance web page to less important web page, okay? There's an algorithm behind, okay? And this is all about statistics and machine learning and data mining as well, okay? Well, my colleagues who talk about the data science program will have some more information about it, okay? Okay, so these three areas, okay, are the major areas of mathematics, okay? And let's say something about what's so special of our own mathematics bachelor degree program, okay? So what's special about us is there are three things, okay? Well, we have a diversified curriculum, okay, that caters different interests of different students. Okay? So some students may be interested in more abstract level of mathematics, pure math. Okay? Some people want to make use of math to do some applicational projects. Okay? So we have about 40-something teachers, okay, in our departments. Okay? And many of them have different research interests, different expertise. Okay? and therefore we have a lot of different courses offering some on pure math, some on applied math, and some on statistics. Okay, and so if you're interested in just one of them, you can find many courses in our math program. Okay, I will elaborate more on this, and then also we have several tracks that prepare you for different kind of career. Okay, not only just for teaching and research, but also in other areas, programming or financial math. Okay, as well. Okay, and more importantly, so it's a matter of fact that different students, even if they're in the same year, okay, they may have different level of mathematics. Okay, some really smart students, they may be able to handle year 4 courses when they are year 1. Okay, and there are some weaker students still. Okay, if you combine all these students together in one class, it's impossible to teach them. Okay, so we have many different level of courses that offering you to cater different initial background, to cater student with different initial background. Okay, so let me elaborate on all these. Okay, and so what I mean by having a diversified curriculum that cater different interests, okay, is we have 7 different tracks in the math program. Okay, so if you want to major in math, okay, you first choose science school, the A program. Okay, that is in the JUPAS we divide into A and B. Okay, it's the A program consists of mathematics, physics, etc. Okay? And then you just go along the A, which is in the JUPAS course 5102. Okay? And in the year 1, you study more like general subjects. Okay? And in year 2, okay, you'll be choosing one of the tracks here. Okay? So this is a list of 7 tracks. Okay? And then you choose one of them in year 2. And then after year 2, we'll, depending on which track you are choosing, we will decide a different curriculum. We will assign you different courses for you to take. Okay, so if you are in the pure math tracks, we will study those number theory. Okay, and applied math, you'll study the imaging processing problems that I mentioned before. Okay, etc. Okay, and the last one is the general mathematics. So some students are interested in some of these areas. Okay, they may be interested in some topics in pure math. Okay, and some topics in financial math. Okay. In the general math track, you can cook up your own curriculum. So if you just take enough courses in math department, no matter what you take here, just take enough courses, and then at the end, if you have done enough, okay, then we'll give you a degree in the general math track. Okay, so you can create your own curriculum if you like. Okay, okay. So this is what we are doing in order to cater different students with different background and also different career goal. Because if you want to get into the computer science field, okay, it may be better if you try to choose maybe the computer science track. And it's actually possible if you turns out you find that both major, okay, computer science and math, okay, you have talents and also you have time to handle both majors. Okay, and then in year 3 you can apply for double major, and you have to you apply through the computer science department, of course. Okay, and the same for physics track. Okay, math and physics track. Okay, if you take enough physics courses, okay, and then in later years you can upgrade to become a double major in math and physics. Okay, so and then let me say something about how we do in order to cater students with different background. Okay, so as I said before, even comparing year 1 students, there are many students who are, most students are average, okay? But there's some really elite students who just jump off the page and then they're able to study some year 4, even year 4 courses, okay? So we'll do something to cater cater students with different level of math, okay, when they enter our program. So even in year 1, okay, we have 3 or 4 different calculus courses. Okay, so I took the picture from one of the popular Facebook forum. Okay, and they illustrate how different they are. So there's the crow that is the further distance within the earth, okay, or within the world. Okay, because the top one and the bottom one, they're just year 1 calculus, but they taught in a very different way. So the bottom one is much more difficult. Okay, and so in year 1, what we'll do is we try to look at your M2 and M1 scores, okay? And if you got M2 5-star or above, okay, we'll put you into an honor calculus program, 1023 and then 1024, okay? and then you will study a difficult and also challenging topics in calculus, okay? And if you do M1 on M2 without this grade, and or maybe above a certain level, let's say level 3, okay? Then we'll put you into the middle one, okay? And then those without M1 on M2 or they did quite badly in the exam, okay, in the DSE, okay, then we'll put it in the bottom one so that you can catch up with the others, okay? So that's what we do in the year 1, okay? And in year 2, we'll also do similar things, okay? And in each of the most important course, okay, for example, linear algebra, analysis, they are all most fundamental mathematics course, okay, for a math major. And each of them will divide into 2 courses. So one is the honor one is the regular one, okay? So the red ones are much more difficult. So if you want to do PhD degree or master degree later on, okay, it's better if you enroll in the red one, okay? The honor one, that will give you much better preparation for you to go into graduate school studying PhD and masters, okay? Well, they're more difficult than the black one, and of course, you have to put a lot more efforts into them, okay? And so therefore, we have some bonus, okay, if you do well in all those honor courses, okay? We have a scholarship program that's named after a Chinese mathematician, Chen, okay? And that class is called a Chen class, okay? It's an enrichment math program that is specially designed for talented math students, okay? And if you're able to do all these honor course above, okay, with excellent grades, okay, then at the end, maybe the top 1 or 2 students, okay, at the end of the program, okay, they can receive up to 50K Hong Kong dollars of scholarships, okay, for their academic excellence if they get a really amazing grades in these courses, okay. That can be used to support them to go overseas for exchange program because you can use the money to maybe buy the ticket, air ticket, or pay the living expense, etc. Okay. So this is what we do for catering different students with different background. Okay. And let me also highlight one really great features or merits about our math program. Okay. That's we are very flexible. Okay. So what I mean here. Flexible mean here is actually it's very easy for students, okay, especially those academically capable students, okay, to take courses ahead of the recommended pattern. Okay, so that means if you're year 1, you think that you can handle year 2 courses, okay, you can just go ahead and talk to the person who teach the course, okay, the course instructor. So if the course instructor teaching that year 2 course, okay, if they think that you're okay to take that course, okay, getting the approval, then you can get enrolled into a year course. Okay, so if you are a year 1 student, as long as the instructor approves, okay, you can enroll into a year 2 course early. Okay, actually, I was teaching a year 2 course online analysis 1 last semester. Okay, and I approved about 15 year 1 students taking that. Okay, and actually they did better than actually on average they did better than year 2 students. So it's really amazing. Okay. And more important, so now, okay, if you take course early, then what do you do if you are in year 4? Okay, if you may end up taking all undergrad courses, okay, and actually also it's possible for undergrad students in our university, okay, to take graduate level course. That means PhD and master level course, okay, as long as the instructor teaching that course approves you, okay. So if he or she approves you, even if you're undergrad students, you can enroll into a graduate level course. And that's a very great thing if you try to apply for PhD program or master program outside or even in UST, because that should give you some bonus, okay, if you have already taken some graduate level courses. Okay. So keep this in mind if you think you're a very talented student, you want to take course ahead, okay? And also because of this flexibility, we don't have a separate independent elite math program that you can apply in JUPAS, because if you're in our math program, okay, our flexibility here, okay, allows you to do this kind of early, to take this course early, to take year 2, year 3 course early. So we don't have a very separate program to cater the top students, because the top students here can do advanced courses and also take the courses ahead of other students freely as long as the instructor approves you. Okay, so So keep that in mind if you think that you are one of the best persons in high school, and then you think that you want to take this advantage. Okay. Okay. So let's say something about our people. That means our faculty, our teachers. Okay, and our students, alumni. Okay, and let's say something about our faculty. So if you try to look at the web page of our math department, okay, we have a list of faculty. Okay. A page listing all the faculties, and then also listing their PhD granting universities. Okay, so you can see many of our teachers. Okay, they got their PhD in these top universities. Okay, and also many of them have some notable research accomplishments. Okay, and getting some really prestigious prize. Okay, on research. Okay, well, so if you want to do research later on, okay, it will be better if you engage in research early with some of the top researcher, and so that you can get a jump start in your research career. Okay, but I guess majority of students may not target at doing research in the future, so they care more about teaching. Okay, so let's say something about teaching. Okay, so teaching. This is a list of some of the best teachers in our department. Okay, the prize on the left. Okay, university prize to reward the excellence in teaching. Okay, but I want to draw attention to the list on the right. Okay, so every year, okay, our students have a election to elect what they think to be the best 10 lecturers. Okay, they have an election, they have a booth setting up in the atrium of our university. Okay, and then the student will vote. Okay, for the best 10 lecturers, what they think to be the best. Okay, and we have, in particular, two of the faculties, namely Professor FONG and Professor Lee. The first two are listed there. Okay, they won this election for many times. Okay, and UST has around 30 years of history. Okay, and I think this election may have around 20-something years of history. Okay, and amongst these 20-something years, okay, these two colleagues, okay, Professor FONG and Professor Lee, okay, they won respectively 12 times and 9 times, okay, and that's really impressive. Okay, so they are really good teachers. It's not the university think that they are good; it's the students think that they are good. Okay, so actually they are teaching some required course, okay, namely analysis and multivariable calculus. So if you're doing a math degree, okay, you will have high chance to be taught by both of them. Okay. Okay, so that's about teaching. So let's say something about our current students. So one really impressive a group of students is that we recruit them in 2 years ago. Okay, 2 years ago we are able to recruit altogether six very talented IMO medalists, International Mathematical Olympiad medalists. Okay, so 2 of them actually got the gold medal twice. Okay, and they are year 3 students right now. They're doing very well. Okay. And also there's one from Hong Kong, okay, who are right now also year 3 students. And I believe he took my year 4 class when he was year 1. And he did really amazing. It's one of the best in the class, okay. So this page shows a alumni. So that means he graduated already. So he's a alumni of us, okay, in the math program in the pure math advanced track, okay. And he graduated 2 years ago in 2008, okay, 1 year ago actually. Okay, so well, one amazing thing that he did is not only the top grades, okay, that he got in the university, okay, but also that he was able to publish 2 papers, 2 journal papers, just as an undergrad student, okay, and one in physics is in Nature Communications, okay, and another paper on differential geometry is published in Communications on Analysis and Geometry, okay, and some PhD students, okay, if they graduate, especially in math, okay, and mostly may have only maybe 1 or 2 papers, okay, for the average one. The best one may have 5 or 6, okay, and many of them actually doesn't have any published paper, even if they got a PhD, okay. But this student, okay, when he was an undergrad, he was already written 2 papers, okay, and well, because he's really excellent, so we sponsor him when he was a year 3 student. We sponsor him to go overseas to visit some other researchers in these top universities, okay? And now he's doing a PhD program in Columbia University under our full scholarship, okay? Well, so you may ask, okay, if you're not going to do any like research or you're not going to further study in PhD, okay? So what kind of career prospect you can pursue, okay? So before I talk about our situation, so let's show you some survey about US and UK, okay? So they are very interesting survey, okay? So the right one about the UK statistics, okay? So they list the top 10 major that they think is the highest, this graduate there, okay, has highest starting salary, okay? And interestingly, they rank mathematics as number 10, okay? And if you look at the left, it's the US data, okay? So there's a certain firm, CareerCast, okay? They select 10 so-called best jobs of 2014, okay? So what this best job is about is they just don't count, just not only count the salary, but also count how comfortable the job is, okay? And then they rank mathematician as top 1, and also the top 4 are also about mathematics, okay? And also actually the second one, also partially related to mathematics, is university professor. So math professor is also university professors, okay? So you see, at least in overseas, okay, math degree is highly regarded, okay? Well, of course, this is the data for overseas, is for US and UK, okay? And well, let's look at our data. So let's just look at the numbers, okay? Look at the salary, okay? Because unless you're doing some like really professional career, let's say a medical doctor, okay? And most of the graduate, I think, when they get out of university, they graduate, okay? The first job is usually in the starting salary doesn't differ too much, okay? Doesn't fluctuate too much, okay? But more importantly, you should look at also what kind of jobs you're able to do after graduation, okay? And then in math, because our program offers you a lot of different tracks, okay? They are able to find different sectors to start their career. So not only on teaching or further studies, they can find jobs in banking, finance, and etc. Okay, because we have a computer science track, also financial mathematics tracks, and you can enroll that, and then you take a lot of these courses, and it'll get you better prepared for this kind of career as well. Okay. Okay, so this is the statistics, and so last, let me say something about is the math program for you. Okay. So what kind of person is suitable to do a math degree in university, okay? So I think math is very suitable for persons if you want a flexible curriculum. So we don't have a very fixed study pattern, okay? A fixed list of courses you have to take. We have some, but all the other higher level course, you have some flexibility. You can choose different tracks to work with, okay? To work on, and you don't have to really fix on a list of required courses, okay? So if you like this kind of curriculum, so our math program is suitable for you, okay? And also if you haven't really decided what kind of career you want to do in the future, okay? So some people may want to do a PhD later on, but you're not sure about whether you can do it, okay? Or you're also trying to look at other career as well, okay? If you haven't decided, okay, you want more career options, okay? And because our program has different tracks, okay? And you can choose your tracks according to your favorable career path, okay? So if you want a more flexible career development later on, okay, then our math program is suitable for you as well, okay? And of course, if you're strongly interested in math and you want to be a professor later on, okay, we have an advanced math program for you to get you prepared for PhD and master as well, okay? And one nice thing about math program compared to other science and engineering is we don't really have to do labs, okay? But there may be some lab in some core course in year 1, okay? But after that, the math courses, okay, I don't think any of them require you to do any labs, okay, or writing lab reports, okay? So keep that in mind if you think that you're really not really a lab person, okay? You want to do things on papers, but not on apparatus, okay? Then keep that in mind if you want to do something related to science and engineering, but if you don't want to do any laboratories, okay? Okay, so let's say a few words about if you want to major in math in university, okay? Then what should you do in order to get prepared for it, okay? As a high school student, okay? So one really important thing is when you're high school, okay? try to understand clearly the conceptual aspects of your curriculums, okay, including the math core and M1, M2. Try to understand the concept, for example, in M1, M2, okay, you know how to calculate derivatives, okay. But why derivative has something to do with the slope of tangent line, okay. If you don't understand the meaning, that will be very difficult for you to study math further, okay. For example, just one example, okay. So try to understand the conceptual aspects, okay. What it really mean by limit, for example, okay. And try to ask why, okay. Don't just look at the solution and try to see how the question is done. Try also ask why a certain question or certain problem is done in the way that they are, okay. And if it's possible, okay, try to get a copy of the old Hong Kong ALE pure math textbook to study that by yourself, okay, or study with your teacher, okay. And because those old materials are actually very useful for the university mathematics, okay. I mean, give you a much better preparation for it, okay. And if you have free time, okay, try to look at some free resources online, okay. There are many free courses in YouTube, Coursera, MIT OpenCourseWare, etc. Okay, they have a lot of really excellent teaching materials and also lecture videos, okay, by some of the top professors in these universities, okay, and they're all usually free, okay. So try, if in your free time, let's say after your DSE, try to look up those videos to get prepared for university mathematics, okay. So that is what I suggest you do if you want to further studying math in university, okay. Okay, so hope to see you in the near future in our beautiful campus, okay. So goodbye.